wait or access the other's computer which has the access, your friend's one, the door next to yours, okay? Anyone who has problem for accessing that network? Yeah, 20, 25, I'm not sure that's the limit for the access at the same time. If this is Windows Server, there's no problem. But this is Windows 7, so you have that limit. Sorry. So that is why I'm saying you should be proactive. Get earlier, occupy the front-end computers, and access it, open it, and keep opening. First come, first get, okay? So but even if you don't have access, you can access it on your friend's computer so that you can create or submit your file, download the material, whatever. By the way, okay, now you have the folders. The folder is uploading your file. Whenever you finish your lab exercise each week, you have 3, 4, 5, sometimes 7, 8, 10 files. Save your file, copy under your name folder, okay? And I'm going to copy this student folder each week. Probably 2-3 hours after the class. That is why I'm saying you're supposed to finish everything within class hour, at least 1 or 2 hours just after the class, okay? That means no homework, no assignments at home. At home, you should do something else for your studio work, other class, or your own work, not for this class-specific assignments or something to do. You should apply the technique you have learned in the classroom to other course or your studio work, real work, okay? Not just for this one. Practicing in real classes, not for this one. That's my intent. So this is the first time, so I let you know this kind of thing first. Now you know network access using this one. This is network computer. The computer name for this one is 504-main, and your computer name is 504-01, 02, 03, 04 through 30. 504-30 is the last one. Numbering sequence is from there to there. So you can find out your computers, your friends' computers, but you don't need to share each other. You can access this computer. But the problem is 30 computers cannot access at the same time. That's the problem. Not my fault. Sorry. So you have to proactive. That's my point. And the 2 backslash is exactly same to this Korean 1 symbol. Just over that just below backspace or just over enter key on your keyboard. Okay. Before getting started, we need to review course syllabus. Okay, please take a look at this course syllabus. And did you put your name on top of it? Don't throw this away, okay? You should keep it. And probably around in the middle of the course, if this is elaborated, I'm going to redistribute this one again. Firstly, let me open this file so that we can share the screen on the screen. As I told you before, this is CAD for Interior Design 2B, but it doesn't matter the name exactly what it is. This is CAD and graphics, not the first class, second class. You have learned AutoCAD and geometric modeling using SketchUp. So our focus is on 3D geometric modeling and rendering using SketchUp. At the beginning of this course, And then we're going to move to 3D Max from next step to next week, according to this course schedule. Firstly, you have to see this one, number, hour, week. Take a look at this number, what it means by. First week, 2 hours, and first week. But take a look at this one. Today, second, 4 hours, and second week. But next week, because of the scheduled holiday season, we have third week, but no hours, no class. So second week, but take a look at those series of four classes, 5 hours, okay? So that you can avoid weekend supplementary course or another meeting in Sunday or Saturday. That means the course gonna be ended in 7 p.m. Exactly 6:50 officially from September 27th through until October 18th, okay? 4 more weeks. Is that fair? Okay, great. So, I told you how to read this column, and the second column shows you main agenda. Last week, we got some course introduction and student self-introduction for sharing some ideas and introduce yourself. And we did something. But this week, main agenda is 3D visualization basics using SketchUp with V-Ray renderer, okay? That's agenda. Topic is here. 3D visualization in interior architecture and some fundamentals of material, lights, camera, something like that. And lab exercise here. Fundamental modeling, but actually today, just V-Ray interface we will handle, and you should submit some rendering outcome from V-Ray using V-Ray plugin on top of SketchUp, okay? The rest of classes, you can take a look at main agenda, 3D visualizations first. That means we're gonna handle renderers first, rather than geometric modeling in 3D Studio Max. We can handle geometric modeling first, but actually geometric modeling is kind of harder work compared to rendering. So I would like to bring your attention and interest first. So we will review V-Ray plugin on top of 3D Max and Mental Ray plugin. Actually, it's not plugin. It's sort of default application on 3D Max. We're going to handle renderers first, and then move on to geometric modeling. That's third agenda, geometric modeling in 3D Max. And then the last one, advanced 3D modeling and rendering issues using 3D Studio Max. And one note, you have to see midterm examination is scheduled in the middle of November, not in midterm October 18th. That's midterm season, but we're gonna have regular course in that midterm season, midterm week. Instead, we're gonna have an exam as scheduled November 22nd, okay? And you can review the rest of course syllabus content. But if the course schedule updated, I'll let you know through the website or updated printout version and so on. Any questions regarding this schedule or course syllabus? Okay, take a look at assessment, course assessment. as you find out, 5 assessments category, all they have same weight, 20, 20, 20, 20, and 20%. That means that midterm examination and final project, assignments here means your submission each week, every week. Today, you will submit three different type of lab exercises. They are all assignments category, but it's pass-fail based, quantitative assessment, evaluation, and attendance 20%, exactly same weight to final project. That means, you know what, no need to say. And class participation 20%. It doesn't mean only the class participation. This includes qualitative evaluation for assignments and attendance, something else. Just simply imagine you gave up just 1 week. You may miss that week's assignment at that week. You can submit a week later, 2 weeks later. But anyway, your pass-fail based submission gonna be some problem. And attendance, participation, they all interrelated. So one absence, it's it makes kind of some correlated effect to your assessment. So that's why I focused on, and I put an emphasis on you should concentrate on the course. What? So combine the course first, and kind of very aggressively involved in the course. Okay? Okay, I think that's enough for the course syllabus. Let's move on to the course material for today. Today's topic, 3D visualization. Until this week, still your computers and the main computer is under the maintenance. That means I need to reinstall entire software on this main PC, and your computers, entire 30 computers should be reinstalled, Windows and software, in next week, in Thanksgiving break, by me. So your computer doesn't have 3D Max so far, but SketchUp and some fundamental software already pre-installed using Ghost and some other software, but not yet prepared 100%. But you may know you have Autodesk student account, and you have your own some online registration key and some activation code. You can get it. For this semester, we're going to use 3D Studio Max 2014 design version. Okay? They're going to release 2015 version next spring. So we're going to use that version until middle of next spring. It changes very fast and so frequently. Anyway, we're going to use the latest version so that we can take advantages of the latest versions, sort of cutting edge and latest modifiers and functionality and so on. Okay, 3D visualization, let's get started. Here I listed up what to do today. By the way, you can take a look at the screen here, or you can open the file that I distributed you, okay, on your screen. So you can take a look at your screen and moving on at the same time, or take a look at my screen. Otherwise, you can open the course website. Google site offers you directly accessing the PDF file that I uploaded, so you can open one of them. Anyway, you should keep the pace with my course material so that you can catch up where we are, okay? First one is lecture, design computing and 3D visualization, 3D design visualization, and technical note and setup, accessing local area network in this room, and something else. Actually, we already did some of number 2, so I think you can skip it. And move on to lab exercises. Probably today's lecture gonna be 1.5 hours. So we can use 2.5 hours lab exercise for rendering scenes in SketchUp using V-Ray plugin. Actually, I prepared 4 different lab exercises, but in probably mandatory submission for number 1, 2, and 3, not 4. We're gonna handle 3 lab exercises, I think. So requirements, at least 3 images in JPG format, maximum 6 JPGs, okay? At least 1 JPGs for final outcome, or you can submit 2 each, so total maximum 6. 3 to 6 rendered images. Try to get your best render shot. That's what you have to do for today's lab exercise. Let me open design computing diagram first for bring your attention again. Actually, when I gave you some kind of special lecture or some additional lecture in last semester or the other chance if we had the same one. But actually, the review purpose, I like to show you this one again. Our department and most of you here aims to do design. That's our goal, right? In design, there is very, very important area should be done by human being. That's something creative and creativity area, creation. That means from nothing to something. That is very simple definition of design. That means we have to build any kind of concept, sketch, visualization, even word or some expression, whatever, should be added on top of nothing. So we have to create something. But that part is very important and something couldn't be done by computers. Only human being, by your brain, you can create something. But the goal for this diagram is design computing. So I would like to show you and guide you the role of design computing. For design, computing works at first, design authoring. Design authoring means you create a concept, a specific thing just brought up in your head, in your mind, that should be authorized by you in a specific shape. Just simply imagine that you have a pen and you just brought up an idea and you can draw something. You brought up idea in your brain, that's creation. And you sketch it, you sketch something, you draw something, that is authoring, okay? But in design computing, you author design using SketchUp, 3D Max, AutoCAD, Photoshop, Illustrator, even PowerPoint, MS Word, whatever you can use. That's computer software. So design authoring is the first one. And then you should develop it. Iterative process. Using computer, you can draw box, you can draw cube, long cube, small cube, and polyhedra, and sphere, and so on. That is design development. And using visualization, you can render it, you can line drawing, visualization, you can make and so on. So analyze your design using computers, simulation, and so on. So in this part, so-called computational processing, nowadays, no one used 100% handmade design process. We all use computers anyway, anyhow. So so-called this computational processing from authoring to development and so on to the final product is so-called design computing in a nutshell. This circle diagram simply shows you that process. So I told you this is human creativity area. Our goal is design. Means is computing technology and design computing. That's the focus of this diagram. Additionally, I would like to introduce you a new area. Creation and computational processing somewhere overlapped. That means, okay, computer, we believe that computer cannot create something, but actually can do in some way, somehow. This overlapped part is so-called AI. You know AI, artificial intelligence, right? Artificial intelligence or machine learning, machine perception, that is kind of cutting-edge computer science area, computer engineering or computer science area. In design domain, so-called design cognition is that term. Computer can create something from nothing. Simply say, Peter Eisenman developed his site planning based on site planning kind of environment existing design. He put the lines according to the environment, and computer suggests the building mass, building shape, according to specific algorithm. That kind of approach is similar to this one. He didn't design that building mass. He didn't design anything about that building. He just put parameters for that environment. So computer can suggest certain kind of geometry for that building. That is one type of that area, okay? Actually, we are not gonna dealing with this part, but there is kind of promising and very something difficult area. So I would like to introduce you this part. If so, what is our focus? You know today's PowerPoint slide title, visualization. Entire semester, we're going to deal with this area for second year student. But actually, my major and our goal, eventually we should go something information modeling. Modeling computational model, not just simply visualization. But our focus in this semester, in this classroom, gonna be visualization. If I have a chance, I'm gonna introduce more and more. But anyway, we should note that our focus is on visualization, geometric shape and their representation in computational manner. That's our so-called visualization. Visualize what? Design. What kind of design? Interior architecture design, building design, built environment design, okay? Your brain, and there is your idea. You just brought up certain kind of concept, certain kind of so-called idea. In conventional architectural 3D computer graphics, so-called CAD, CADD, CAAD, whenever you got your idea, no one can see it, right? Before you are telling your idea to others, or drawing a picture, or make something by hand, you should do something for representing certain kind of idea in your brain. No one can see something in your head. It's still only seen by you, only in your head, your universe of this course. That is why we have to draw something in terms of architectural standard named floor plan, elevation, axonometric, isometric section, and so on. They are all architectural symbol. We can say it. Design presentation, design representation. Mostly we can use PowerPoint for showing your idea to your instructor, studio class professor, or your friends, your clients in the future, right? We don't need to put digital here because you can draw by hand, drawing by your markers, your pencil, any kind of pen you can use. So all here, plan, elevation section, diagram, sketch, slide, pictures, animation. The picture here means you can take pictures by film camera, even digital camera. Anyway, that picture, that digital camera picture is going to be used some analog way, not total 100% digital way. Animation, design panel, printed media. You can print your ideas, or you can tie a book for your concept book, something else. This is conventional architectural visualization. Visualize something from your head. Very simple, right? The problem of this work is repetitive, never ending sometimes. Because your idea is not perfect, you have to modify your idea again and again. So you got idea A, visualize A, you modify A dash, you should revisualize A dash. You got B, so made B again, B dash, C, D, never ending story, right? That's your usual walkway in your studio, conventional way. Also, your focus was geometric drawing and drafting. If you think about circle, you draw circle. But what if you just define, okay, just say computer, okay, I just start circle. Don't draw circle. Draw circle whenever I order it, something like that. That's totally different way. Hopefully you can understand what I mean by. But anyway, this is conventional way. But now we got the term modeling. Modeling. Okay. I would like to differentiate the term between modeling and rendering. But let's take a look at this slide first. The same brain, your brain, same idea, but a little bit different way. Formerly, we directly draw something using computers. But at this time, you can use kind of intermediate media, intermediate file, something else, named computational model. And you can extract this kind of representation, visualization stuffs from this model, not directly from your head. That's big difference is there. Same plan, 3D sketch, pictures, even animation, anything else from the model, but not directly from your brain. You don't need to draw it. You can extract from your computational model. That means simply say one source, multi-use. How about this one source? Of course, it's not easy to create this model, computational model, properly, correctly. But good thing from this one is you don't need to get again and again some repetitive work. If you got some new idea, update your computational model. And all others gonna be auto-generated because computer knows what is your model. So computer can create plan, elevation, 3D, sketch, animation according to this model, not directly from your brain. Okay? You know what's different. So this computational model can be appended amount of more information about the building. That is building information modeling, okay? That is so-called BIM. But our topic is not on here, BIM. That's kind of next year topic. What's this year's topic? What is it? Great. Visualization. Visualization of computational model. Okay. But I would like to tackle the concept of BIM in the middle of our approach to computational model and something else. I would like to introduce you the difference between modeling and rendering quickly, and I would like to elaborate it later. The term modeling here is actually information modeling in this diagram. But whenever you say modeling in this semester, in this course, just simply regard it as geometric modeling. Eventually, we're going to deal with, whenever we say modeling, that's going to be information modeling about building. So that is BIM, supposed to be BIM, but again, not this semester. This semester, whenever we say modeling, whenever I say to do some model, doing modeling, that is geometric modeling, okay? Within building information modeling, geometric modeling is a subset of building information modeling. Simply say, this is BIM, and this is geometric modeling, okay? A subset of that. But our focus this semester is on here. Let's move on to the topic issue in digital design, media, and computing. The simple representation about design mode from Wikipedia. Actually, we have to know what is design, how to define design, something else. But instead, I would like to show you there are very particular 3 different modes in general design. First one is mode of thought, and then move to mode of expression. The last one, mode of production. First one, mode of thought, that's simply similar to the image I showed you before, brain, your idea in your head. In this mode, design is a plan, a scheme, on abstraction, abstract. Abstraction of something real, but that something real is only seen by you. So you have to make a concept or some replaced keyword or image, something like that. So that is why we say abstraction and a plan in this mode of thought. Actually, this is not our focus here, which generates ideas and concepts. On abstraction, which generates ideas and concepts. Very straightforward. Our focus is on actually here, mode of expression. Design is also a way of taking thought systems, blah, blah, and visual equivalence. Visual equivalence means in your thought, you thought circle, and then you should visualize it in circle. You thought rectangle, draw rectangle. That is visual equivalence, kind of. But what if you thought rectangle, but you express triangle? You draw triangle. They are totally different. But no one knows that's different because no one can see your brain, your idea, your concept. So whenever you say your concept, my concept is apple, you should draw apple or something like apple. That's visual equivalence, simply say. How to do that? Exploiting a media, a medium's unique qualities to maximize meaning. The term here simply means that if you want to use a pen, you know the characteristics and the function of the pen. So maximize the meaning, your meaning apple. So you have to draw an apple, shadow it, and make it something real apple. Exploiting your media, because at that time your media is pencil. Whenever you use computer, AutoCAD characteristics can be applied in this kind of expression. SketchUp, same situation. 3D Max, too. Finally, mode of production. Design is finally a way of making artifacts. Very straightforward. In this diagram, my keyword is here, medium. What is our medium for this semester? Yes, 3D Max. Or some other 3D software, because our course title is 3D graphics. So SketchUp 3D, 3D Max, Rhino, whatever you can use. But for your skill, for geometric modeling, mostly we're gonna use 3D Max. That's the scope and kind of scope of the class. Let's talk about design media. Design by hand. Design by hand for several thousand of years, I think. If we draw a line, this is 2013 now, and this is, I'm not sure, BC 20,000? I don't know the correct numbers, but anyway, when a human being created, they use that, something like that, right? How long? From here to somewhere here. Actually, it's shorter than this one. Here, 1944, 3, 5, I'm not sure. The first computer named ENIAC, I don't know, it's not important. That computer invented, and 1990, computers in design company, design office, architectural design office. 1998, I'm not sure the correct year, SketchUp released. 2000, thanks to hardware speed and cheaper memories, regular people could use Revit, so-called BIM. So as a design media, we only use pencil and something like pencil, very long time. And the period for using computer, really, really short. Very recent record. But anyway, nowadays, no one uses so-called design by hand. We always use design by computing. Even if you draw something else by your sketch, from your sketch, your expression, visualization at the first stage, anyway, you have to move on to computational manner. Design by pencil to computing. Thanks to computer hardware and software environment, the pencil is one of the most basic media of design. Pencil is media, another medium